Look at the Antarctic landscape, and it appears entirely frozen in time. But underneath that quiet sky, the ice is in a state of constant, relentless motion, slowly creeping toward the ocean. This visualization maps the true scale of that moving mass. We are looking at over 27 million cubic kilometers of ice. If all of it melted, global sea levels would rise by 58 meters, enough to submerge the coastlines of most major cities on Earth. As warming ocean currents increasingly erode the edges of these glaciers, scientists urgently need to predict exactly how fast the inland ice will flow into the sea. But those predictions have been stalled by a massive blind spot. To calculate the speed of a sliding object, you must know exactly what it slides on. The rocky terrain hidden deep beneath the Antarctic ice sheet acts as the primary control mechanism for the continent's ice flow. Without a clear map of that bedrock, estimates for future sea level rise remain incomplete guesses. To map the hidden floor of the continent, international research teams spent the last 6 decades bombarding the ice with radar and seismic sound waves. Early survey teams collected this data by hauling their equipment across the harsh, sub-zero landscape on dog-drawn sleds. Over time, the methodology evolved. Researchers began mounting radar equipment onto ski-equipped planes, flying long grid patterns to gather over 82 million individual data points. The culmination of that effort is a digital mapping project called BedMap 3. By mathematically stripping away miles of ice, it reveals a violently jagged, deeply scarred rocky continent. Think of this topography like syrup poured over a rock cake. Every hidden bump dictates the flow. Sharp bedrock ridges act as natural breaks, compressing the ice. But where terrain dips into deep hollows, the ice loses friction and rapidly accelerates. The scale of these hidden features is extreme. Survey data revealed an unnamed canyon in Wilkes Land holding ice nearly 4,800 meters thick, more than 15 times the height of the tallest skyscraper in Europe. This hidden topography operates as the ultimate mechanical gear system for the world's largest ice sheet, providing the brakes and accelerators controlling its flow. The physical shape of the bedrock is coupled with a second invisible variable, geothermal heat. A newly released digital archive, known as ANTSGV-25, has compiled the exact locations of 207 subglacial volcanoes buried entirely beneath the ice sheet. The sheer volume of these discoveries forces scientists to reclassify the continent's geology entirely. Antarctica is actually one of Earth's major volcanic provinces. These subglacial volcanoes don't erupt with ash. Instead, they act like giant radiators, projecting intense geothermal heat into the ice's base. This actively melts the bottom layer, creating trapped water networks. This liquid acts as a high-pressure lubricant, allowing the ice to rapidly slide. A massive geothermal engine actively greases the continent's underbelly, keeping the world's largest ice sheet in constant, fluid motion. When you combine these two variables, the danger compounds. A steep, downward-sloping valley that is also being lubricated by volcanic heat creates the perfect conditions for rapid, unchecked ice loss. Antarctica functions as a highly dynamic and structurally vulnerable system, constantly responding to these massive hidden geological pressures. Because the BedMap 3 data shows that massive volumes of this ice rest in deep basins well below sea level, it is highly exposed to warm ocean currents cutting in at the continent's edges. The topographic data from BedMap 3 and the thermal catalog of ANTSGV-25 finally provide the precise mathematical inputs needed to run accurate global climate simulations. Researchers are using these comprehensive maps as active predictive engines. They scan the hidden topography and thermal hotspots to pinpoint exactly which sections of ice are at the highest risk of imminent collapse. To accurately predict how high the tides will rise along the world's coastlines tomorrow, scientists first had to uncover the massive, chaotic geological world actively operating at the bottom of the Earth today.